So this is review for your upcoming final. What does AROC stand for? Good? What does it mean? Yeah, it's just a slope, right, between 2 points on some function. So I've put the graph of this function up here. And keep in mind that these two values, these are both x's. So maybe call them x1 and x2, but it's not a coordinate pair. It's two x values on an interval. So we want to look at -1. And so on this graph, -1 is roughly right there. And then what was the other one? -1/2 is roughly right there. Let me do those in a different color. Okay, so those are the two x's, and from them, just using the graph, we can put the points on there. Okay, so basically we're finding the slope of this line, which obviously is different. The average rate of change for a parabola is different depending where you look and depending which points that you pick. Think about if I had picked a point up here, now my slope is very positive instead of very negative. So it's completely dependent where we're looking on our function. And this is actually a pretty important concept in higher level math, the idea of rates of change. And then this is called average. And then you start studying instantaneous rates of change, like what's happening right now, not over an interval, but right at the moment. Okay, so think about what that would look like. What's the slope if I just look at that point? Let me use pink. If we just look at that point, what would be the slope at that single point? Well, do you see how that's the line going through that point? And what's the slope of that horizontal line? What's the slope of any horizontal line? 0, right? So at that point, right at that single point, this graph has a slope of 0. But if we turn the corner just a little and maybe go here, now our slope is quite positive, okay? And then if we go up here a little further, now it's even more positive, like even steeper, okay? On the other side, it's negative, getting less negative, less negative. So if we look at a point here, it's not super negative. But do you see how it's changing constantly? Okay, that's a huge concept in math, that what we just talked through, the idea of rates of change and slope. So average rate of change for your next, those of you going on to the next levels in math, this is one of the most important things we've talked about, even though it didn't take long to talk about it. So just a reminder what we were talking about, like what it all means, and here's your reminder for how to find it. You didn't have a graph, which is totally fine. Most of the time you don't. So what does f of b minus f of a mean? Yeah, good. So maybe just to be consistent with that, let me call this a and b instead of x1 and x2, but it's the same idea. Okay, you have two options. You can plug -1 into the function here and -1/2 in here and have a huge numerator, which is fine. Or you can go do separate calculations, like you can come in here and say, what is f of 1? And this might be a little neater. So f of 1 means we're plugging in 1 to this function. And 2 times 1 squared. Do you do 2 times first or the squared first? Like, this is a common mistake that students still make, so I'm asking square before 2 times, right? GEMS or PEMDAS, whichever one you learned, says exponent before multiplication. So don't do 2 times 1 and then square that. That would be wrong. So this is just 2. Like 1 squared is 1 times 2 is 2. And then -2 plus 1 Okay, so what is f of 1? Just 1, okay? And then we'll need f of negative, I messed up. This is supposed to be -1. Sorry about that. Let's go fix it. Doesn't change the first term, but it does change the second term. There we go. Okay, so 2, that's still the same, but -2 times -1 is +2, so it should be 5. Okay, and then let's do -1/2. So again, we're just plugging that in the function. And can you shut the door now? Thanks. Okay. Guys, don't let these fractions, they're no big deal. What's -1/2 squared? It's 1/2 times 1/2, right? It's not times 2. So what's a half times a half? It's a fourth, and it's positive, because when we square stuff, it's always positive. Okay, so it's a fourth times 2. I'll write it as 2/4 for now. Okay, and then over here, what's 2 halves? It's positive because they're both, it's negative times negative, but what's 2 times a half? Just 1, right? So this is +1, +1. Okay, well, what is 2/4? It's a half, and then, of course, 1 and 1 makes 2. So this is 2 1/2. Let's write it as 5 halves, maybe for now. I'll write it both ways. Okay, so we found f of -1 and f of -1/2. That is f of b and f of a. So that's our numerator. So we're ready to go find the average rate of change now. And that's going to be 5 minus 5 halves, or 2 1/2. Okay, and then make sure your a and b match in the denominator. I have it backwards. Sorry about that. It doesn't actually matter, but based on the way I've labeled it, I need to write it this way. So 5 halves minus 5, and -1/2 minus -1. You need both negatives on there. Okay. Again, it doesn't matter. If you called, back up here, if you called this B and this A, fine. No big deal. Just make sure you match the order when you get down here. It's got to be B, B, A, A, or A, A, B, B. Don't mix those up. Okay? Which point is A and which point is B? Who cares? That doesn't matter at all. All right. What's 5 halves minus 5? -5 halves, right? And if you do 2 1/2 instead, 2 1/2 minus 5 is -2 1/2. Okay? What's -1/2 plus 1? So minus minus becomes plus. +1/2. Okay, so we just have this little fraction deal here. Honestly, you decimal people, it's usually easier to do it with fractions. Okay? And the reason why is this would be, if we had it as decimals, it would be -2.5 over 0.5. This one's not too bad, but I mean, if you just look at this fraction, I don't know if you can see this, but I'm going to show you. We have 2 in 2 denominators, so they just cancel. Okay? And so what do we have left? Just -5, right? Does that slope that I drew on the picture look like a -5, or like it could be a -5? Yeah. Okay? So this is the average rate of change between those 2 points. And again, if we change the point slightly, the average rate of change is going to be different. How'd you do? Okay. So if that's like, whoa, I don't remember that, you have 2 weeks till your final. Actually, a little less. So be studying. It's extremely more effective to study little by little than to try to cram the night before. Just so you remember that. Let's check your homework. Hopefully more of you did it than it showed yesterday. Okay, number 5. Was already factored, so that was nice. You had two zeros, one at -3 and one at +2. And they both had multiplicities other than 1. So it made the graph a little bit more interesting. And I put the arrow there to the negative, which means it's the odd negative end behavior. So I wrote reversed. And how do we know it's odd? Like, what is the degree, I guess is what I'm asking. Yeah, it's 5, because this x is to the third, this x is squared, and when we multiply those, it becomes a 5th degree. And then how do you find the y-intercept? I didn't show the work, I just wrote the answer. How do we find the y-intercept? Yeah, so this becomes negative, and then 0 plus 3 cubed times 0 minus 2 squared. Okay? Well, of course, the zeros don't really need to be there, so this is just 3 cubed and -2 squared. With the negative out front, don't lose that. So this becomes -27 times 4, and then there's your 108, your -108. Okay, so I told you on Tuesday, like, don't go scale your y-intercept, just draw it down there and label it. We're not going to scale down 108 spaces or something, okay? But do call it out, that means label. So how'd that one go? Oh, and I should mention, multiplicity of 3 means it curves through, and multiplicity of 2 means it bounces off. Now, how do we know if it curves? You know, it could curve this way or the way that I originally drew it. How do we know? Yeah, it really depends on the end behavior. Which way is it coming from? So like this one, it's coming from up here, so it's got to curve from left to right. Curve down, maybe we'll say. Okay, it wouldn't make sense for it to curve the other way. So don't overthink that. It's pretty natural once you start graphing the end behavior. It flows pretty well. Any questions on that one? All right, let's talk through these other two. If you want to take notes on steps, here's what I would write. Identify the zeros would be the first thing. So what are my zeros? Negative like 2.5 or so, okay? And 0 and positive 1. Okay. Next, write the zeros as factors. Okay, how would I do that? Well, basically you just bring the value over with the x. So I'll do the first one. X equals -2.5. If I just add 2.5, and you can do this in your head. It's not like you have to write it, but I'm just showing you what we're actually doing. Okay. Do you see how it would be back to factor mode now? Okay. So our factor for that one would be x plus 2.5. Now, honestly, it's not going to show up that way. It'll probably be like, what would it be? 2x plus 5, and then we would divide the 2, right? I don't actually minus 5. Sorry about that. No, never mind. It's negative. I'm not going to worry if you wrote it that way. Okay, what would the other two be? Maybe I'll put it up here. There's one factor. What's the next one? Or at least potentially, what's the next one? It's just x, right? It's already by itself equal to 0. How about this next one? X minus 1, right? Okay, so if you subtract the 1 and make it equal to 0 again, that's like going backwards from solving. It would say x minus 1. Okay, step 3, identify the multiplicity of each 0. Okay, what's the multiplicity of negative 2.5? Yeah, it's probably 3. Because it curves through, right? It's not just linear passing through, it's curving. So the multiplicity, I'm going to say, is 3. How about at 0? It's 1 because it just passes straight through. How about at 1? 1. Okay, and so your last step is just to write it out in factored form with the multiplicity as an exponent. So write in factored form. As exponent. Okay, so we'll call this f of x. It has to have a function name. It doesn't have to be f, but pick something. Okay, let's go with 2.5 just because I know everybody follows that. This is to the third since it's curving through. And then we have x and x minus 1. Those are both just to the first power. And honestly, we usually write the x, those single terms out front. So I would probably finish by writing it this way, but this is mostly just preference. How'd you do on that one? Now, we do have to address end behavior. So I'm going to put that as your final sign, or final step, excuse me. Check end behavior for LC. What does LC stand for? Lead coefficient. So right now we have a positive lead coefficient. Is that matching what our graph shows? Yeah, okay. So I'll put a plus there. It doesn't need to be written, but just to remind you. Okay, let's do the one down below. And this time I won't write out all the steps, but we'll just do them. Okay, what are our zeros in this case? Negative 2, negative 1, 0, and okay. What is the factor for, let me title these, I think. 0. Factor, multiplicity. Okay, what's the the factor for x equals negative 2? X plus 2, awesome. Put it in parentheses because that's how it will look in our final form. How about for x equals negative 1? X plus 1. How about for x equals 0? Just x, and x equals 2? X minus 2, awesome. Okay, what's the multiplicity of x equals negative 2? Just 1, it goes straight through. How about negative 1? This one's a little tricky, Alex, by the way. I'm changing what we talked about. If you look really close, it does just pass straight through, then it curves. So it's not curving on the 0. Does that make sense? If it was going to do that, it would look something like this. You know, it would curve right at the 0, but it's not. So it's curving after it passes through. So it's actually just a multiplicity of 1. Okay, how about at x?
2.
Good. It bounces off, so it's 2. And then also 1 again. Okay? So now we go write this list out. Oh, and what's our end behavior? This time it's a negative lead coefficient, right? So we don't know what it is. It could be negative point something, negative 10. We don't know the number. It doesn't matter. We just need the sign. So we're going to say f of x or some other letter and then put negative. And this time I'm going to write the x first and then just list these out. Okay, and then we put our squared on that x. The negative sign is what makes it match the correct end behavior. How'd you do on that one? Okay. But it doesn't feel too bad now that I've kind of shown you, hopefully. Okay, good deal. Any questions on it before we move to the next thing? I want to give you some time to work today. So today I don't really have notes, just a couple examples. And then it's time to work. So read this one. And tell me what you think. I can zoom in if it's too small. What is a complex zero? What is a complex number? Do you guys remember that? So this is good review for your final as well. Remember, complex numbers are in the form a plus bi. So we have that imaginary component, a plus or minus bi. Okay, but here's the thing. Look at the function. Can you factor that? Like we know we want zeros, so we have to factor, but can you? Well, do you remember? Whoa, that's cool. Do you remember on Tuesday I showed you factoring by grouping in the packet? Okay, that's an option. I'm not saying it works here, but check. Can we factor this by grouping? Well, remember, to factor by grouping, you have to be able to create the same factor in parentheses. So if we pull out a GCF out of this one, it would be x squared times x plus 1. Over here, is there any way to make this an x plus 1 inside parentheses? Like, can I pull out, the only common thing I see is negative 3. If I pull that out, I get x plus 2. Well, that's not the same, okay? So does this work to factor by grouping? No. Okay? So say no, if you're writing with me here, no factoring by grouping. Okay, well, good news. We don't have to in this case because we're given a 0. Do you see that? What's the given 0? So I'm going to say it like this. Who cares? We have a 0. Right there. Okay? So our 0 is at x equals 2, which means we can break this function down from a cubic to a quadratic using what? Yeah, good job, Anthony. So use synthetic division to break down. Now, we're only going to be able to do this once. What goes up here? It's 2. It's our 0, right? The actual 0 goes in there. So it's 2. Okay, you remember synthetic division? We did it on Monday, but we haven't done it since. What do we do first? Drop that 1 down, and then multiply, add, right? So 2 times 1 is 2. 1 plus 2 is 3. What should we expect, by the way, at the end of this? We better have a 0 remainder or something went wrong, right? Because we already know that 2 is a 0. It was shown in the graph. Okay? Anyway, just reminding you. So 2 times 3 is 6. Negative 3 plus 6 is 3. 2 times 3 is positive 6. And we do indeed get 0. Okay. Everybody good so far? Yeah, we're going to use this a whole bunch to do that, yeah. All right, so this is now x squared plus 3x plus 3. Okay. We need to know the other two factors of this thing. Is this factorable by star? Are there factors of 3 that add up to 3? There's only 2 factors of 3, 1 and 3. Do they add up to 3? No. Okay, so this is not starable. So what's our fallback after star doesn't work? Quadratic formula. So how does that look for this? Don't you love math? Don't you love how it just keeps going? It's cool when you start getting to bring in things you've learned, though, right? Like, hey, I know this from Algebra 1, and I know this from 2 units ago, and I know this from now. Okay? Those of you on your way to calculus, you get to do that with every math class you've ever taken in a single problem. It's cool. It's not. It's awesome. Okay, quadratic formula would be negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Okay, and now we're going to continue on. It's going to look like negative 3 over 2 times 1 plus or minus 3 squared minus 4 times 1 times 3 over 2 times 1. Anyway, we go through, we find the zeros from that. Okay? Can you finish that off on your own? Not right now, but later? You can. Okay? Write it down, but then I want to make sure we don't miss the big ideas of this problem. Okay, first thing to note, 3 squared is 9. 4 times 3 is 12. So do you see how this is going to be square root of a negative? So there's where we get the complex part, right? It's going to be, well, 9 minus 12 is 3. So this would be square root of 3i. And then over 2. Okay? So there's not a lot we can do with this. It's going to look like this. I'll just solve it for you. Okay? There's our other 2 zeros. Now, why are they complex? It's kind of cool when you start connecting. They have to what? Okay. Well, check it out. If we shifted this thing up, this whole graph up a little bit, do you see how these 2 lines would make 2 more zeros? Well, that's where the 2 that we just solved for, those complex zeros, are coming from those that don't actually cross the x-axis. So it's like we have the 1, but these 2 just didn't quite get there, so they are complex. They're not real. That's the connection. All right, let's do another one. Well, actually, before we do, let me make sure you don't lose the big idea. You were given a 0. Big idea. If you're given a 0 or more than 1 0, you take it to synthetic and you start breaking down your function until you can either star or quadratic formula. Okay? I'm not saying this problem wasn't to say that all of the time you're going to have to quadratic formula. It was just this one. Okay? If we could have starred that would have been fine. So let's look at this one. This one, actually that one will be the same. Okay, what are the zeros here? Okay, we have a 0 at x equals -2, and x equals 2. Notice that this is a fourth degree. Okay? So what are we going to do to start breaking it down? We have 2 zeros given. What will we do to break it down? Synthetic, right? Okay? So what goes, let's pick one of these. Which one goes in here? Let's start with 2, sure. Okay, don't forget we're missing the cubic term. So we've got to go 0 for the x cubed, and then -3, and then 0 for the x, and then -4. So don't miss those ones you have to fill in. Okay? Why don't you cruise through that? And you remember, this is a 0. We know it is, so we better get a 0 remainder. And we do. Okay. What is the degree of this bottom line? It's cubic now, right? Because it started off as quartic or fourth power. Now it's dropped 1. So now it's cubic. Okay, remember that we don't have to rewrite it out. We can just continue this process. So let's just stick our -2 here and do it again. Okay? Bring down your 1. And start over. Okay, we don't actually need that 0 at the end because that was just our remainder. All right, what's the degree of that result? Now it's squared, quadratic, right? Okay, so we would take this either to star. So this is now x squared plus 1. And so we either star or quadratic formula. Actually, this one we can square root, which is nice. Can you do that for me real quick? Just solve by square rooting. Some of you can probably do it in your head. Set it equal to 0. What's our next step? Okay, what's the square root of -1? Yeah, so positive and negative I. Okay, and where in the graph are those coming from? Think about if we shifted this whole thing up, we have this 0 on this arm and that 0 on that arm. But do you see how we're missing 2 zeros on that section? If we shifted it up, that's where the I and -I are coming from. It's those missing zeros that would be somewhere in there if we shifted this whole thing up. Okay? All right, what if you're given, maybe write this one down wherever you're writing this stuff. We're not going to do this whole problem. This is not going to work. I'm not going to be able to make something up that works. But let me just ask you this. What if you're told this is a factor? Okay, I don't want to try to make up the polynomial because I'll just mess it up and it won't divide properly. But what if you're told instead that of x minus 4, what if it's x minus 4 squared is a factor? What does that mean? Yeah, that means that 4, the 0, 4, is there twice, right? Which means you synthetic divide by it 2 times. Okay? So write this down means, let's write x equals 4 is a 0. And the big idea here is that it's a 0 twice. So synthetic divide twice. That would allow you to break this down 2 degrees, right? By 1, 0. Like let's say it's a 4th degree. You divide by 4, now it's a 3rd degree. Divide by 4, now it's a 2nd degree. And now you can factor or quadratic formula. Okay, so basically what we've studied today is how does this process work if we're given at least 1 0? How do we use that 0 to continue breaking it down so that we can find the other zeros without having to just raw factor? Okay, that's the last thing we're going to do before I hand you a polynomial and say, here, figure it out. There's no zeros given, no graph, just a blank polynomial. I want it factored. Okay, you're going to have 2 theorems that will help you do that. Sometimes it's a lot of work. It's repetitive work, so it's not necessarily hard. It's a lot, okay? It's like folding laundry. It's not really hard, but it gets old after a while. At least that's what I think. All right, I should have mentioned that, well, I will now, but look at just real quick number 6. Oh yeah, this is one of those numbering ones. The one that has x squared minus 9 as a factor. Okay. Can you synthetic divide with that? No. So if you're given a factor that is not synthetic dividable, just long divide it. It will still break it down, and then you can continue. So x squared minus 9, divide by that long division. You start with 5th degree. So what degree will you be at after you divide by a squared? 3rd degree. Okay. And now you can probably, that one you'll factor by grouping. Okay, but look at all these other ones. The other number 6, 2 and 5 are zeros. How are you going to break that down? Synthetic by 2, synthetic by 5. Now you're at a quadratic. Okay, you can factor. Look at number 5. It starts as a 5th degree. That's a nasty looking polynomial right there. Right? But we're told that 3 has a multiplicity of 3, so what are you going to do to break it from 5th to squared? Synthetic divide by 3 times in a row. Okay? And remember, don't start over. Just use that bottom line again and again. Okay? So do you want to do one of these real quick together? Okay. The first 2, the formatting is kind of stupid. That after the comma, that's the 0. It should be a little more clear. Okay. I'm going to do number 4 with you. Do you want to do that? Yeah. Okay, let's do number 4. Okay, it says 5 is a double root. That means it has a multiplicity of 2. What should we get when we finish dividing? Should get 0. We're told it's a root. That's another word for 0. Okay. If you don't, It helps if you don't need a calculator, because then you can do it faster. Okay, we got a 0. It said 5 is a double root. So what do we do next? Yeah, just do it again. Take that bottom line minus the 0. Do it again. Okay. Now what degree is this? Yep, it went from fourth to third to second degree. So now star or quadratic formula. Which one is this? X squared minus 2x plus 8. Are there factors of 8 that add up to 2? Yeah, 4 and 2 do, right? Now, I mentioned this earlier in the week. If x squared is negative, factor out negative 1. It just makes it so much easier. So I'm going to write it as negative 1. And then this will be x squared plus x minus 8. And now just factor the inside. It's so much easier to do it that way. Okay, a times c is 8. Well, negative 8. B is 1. Should have a 2 there. Sorry about that. That should have a 2. It was Sophia's fault. And then a is 1. So what factors of negative 8 add up to positive 2? 4 and negative 2. Okay, both of those are already reduced because a is 1. So this becomes x plus 4 times x minus 2. Okay, by the way, I'm doing what I want you to do for this whole thing. So what is p of x in factored form? Write it in factored form. Well, it would be x minus 5. That's the two given zeros. Squared times x plus 4 times x minus 2. And then if you notice that negative 1 that we factored out, we need to add that back in, right? So it needs to go back in the front. That's factored form. Then you just go graph like you had that homework the other day. Okay? We bounce a 0 at 5, and then negative 4 and positive 2, it just passes through. So something like we have negative end behavior, so it's going to come up through there, down through there, bounce at 5, and come back down. What's our y-intercept for this one? 200. So we're not going to go make that some scale. We're just going to say that is 200 right there. Okay, so that's the expectation for each one of those. And that's going to be due on Monday. We're getting close to this looking like the full process. On Monday, we'll add those two theorems pretty quickly and then start that. Okay, so use the rest of the time to do this and ask questions.